This is a key to the worksheet on factoring number 4. And on this worksheet, you want to factor each of these polynomials. Now, these polynomials, you'll notice, involve the difference of two cubes, sum of two cubes, difference of two squares, and perfect square trinomials. It does cover topics 7 and 8 in your modules in your course. Let's look at number 1. So number 1, we have x squared plus 24x plus 144. Now the way that most students approach this is the approach that they've learned in previous lessons. So for example, they'll notice that the GCF is 1, and so they're going to go directly to factoring as two binomials using either the AC method, or they will use the trial and error method or the reverse FOIL. And so if you look at this, this is the easy kind because the coefficient of x squared is 1 and the last sign is positive. So if you go ahead and you factor this, you'll get x plus 12 times x plus 12. And you can check it and you'll notice that x times x is x squared. 12 times 12 is 144, and the outer is 12x, the inner is 12x. You add them up, you get 24x. Okay? But what I wanted you to understand, though, in this particular worksheet on topic 7 and 8, is that this trinomial is a perfect square trinomial. So it's a perfect square trinomial. And so a perfect square trinomial is a trinomial in which you can factor, in which the factors are identical, so you can write it as a binomial squared. So hence a perfect square trinomial. So when you multiply this out, you get this trinomial, and this is a perfect square trinomial because you can write it as this binomial squared. Now, one of the things I wanted you to recognize about this, though, is that whenever you have a perfect square trinomial, I want you to notice that the coefficient of x is always going to be even. Okay, so it's going to be even. Now, we're assuming there are no fractions involved here, so these are all whole numbers or integers, but the coefficient of x is even. So I want you to notice something. When I rewrite this, I get x squared plus 2 times 12x plus 144. Okay, and so if you look at this, so whenever you write it as 2 times this product, whatever gives you this back, I want you to notice that 12, see this 12, if I square it, I get 144. So that's what you see here. And you see this x, if I square it, I get x squared, and that's what you see here. All right, so a perfect square trinomial will always have that form. It will always be 2 times some factor, okay? 2 times some factor, and the factors of each factor of what I have boxed off will be, when you square each one, you get the first term and the last term. So in other words, 12 squared is 144, x squared is x squared. Okay, so that's how it always looks. All right, but anyway, that was number 1, and probably what most of you did was you didn't even think of this as being a perfect square trinomial, although that's what I want you to recognize. You went directly and you factored as two binomials using either the AC method or you used reverse FOIL or trial and error. Okay, number 2, though, you have no choice but to use our special factoring. And so notice that in number 2, you have a binomial, you have two terms, and so you also notice that the exponents of both the x and the y are cubes, and that the middle sign is positive. It's a plus symbol, right? So you want to check and see if that's going to be the sum of two cubes. Sum of two cubes. And so the formula for the sum of two cubes, and remember this, I'm going to write it as f cubed plus L cubed, will be a binomial, so f plus L, times a trinomial, so f squared minus FL, and then plus L squared. All right, so that's what the difference of two cubes, the sum of two cubes can be factored as. All right, now, so now we're going to see if I can write this as the sum of two cubes. All right, now the way we did it in our lessons was we said this. Well, if I can factor this as the sum of two cubes, then I can fill in these parentheses, and when I cube that, I'll get these two terms back. So in other words, 3 x times itself 3 times is 27x cubed. So 3x goes inside the first parentheses. Y times itself 3 times is y cubed. So this is your f here, and this is your L that goes here. All right, and so according to our formula, then this right here becomes, when I factor, so this is going to be my answer here. So when I factor, I get this binomial f plus L. So f is 3x plus L, which is y, times, and then I square f. Now go off to the side and think about what it is you're doing. So f squared here means f times f, right? Well, f is 3x, so 3x times 3x is 9x squared. So that goes here, 9x squared. Minus, so subtract, and then f times L means I take f and I take L and I multiply them together. So in other words, 3x times y is 3xy. So that's your middle term. Plus, and then L squared. L squared means L times L. Well, L is y. So that means y times y is y squared. And so there's your last term. And so this is your answer. Okay, so that's the answer. So you have a binomial times a trinomial. Whenever you have a perfect cube trinomial, or whenever you have the sum of two cubes, you're going to get you can factor as a binomial times a trinomial. The same thing for the difference of two cubes. It'll be a binomial times a trinomial. All right, number 3. Number 3, you have x cubed minus 125y cubed. So again, now remember, you must always look for GCF first. So the GCF of those two terms is 1. All right, so now let's go and notice that this is cubed, this is cubed. So let's see if this is the difference of two cubes now, because you have a subtraction here. So the difference of two cubes. This time the formula for the difference of two cubes will be a binomial times a trinomial, except this time the binomial is f minus L times f squared plus fl plus L squared. So there's your formula. And so now let's do that little second part here. So we're going to see, can I write this as something cubed minus something cubed? Well, x times itself 3 times is x cubed, and then 5y times itself 3 times is 125y cubed. So I found my f and I found my L. Okay? And now we're going to just substitute into our formula. So the answer is going to be f minus L, so x minus 5y, in parentheses, times, and then I square f. So remember, f squared means f times f. Well, f in here is x, so that means x times x, which is x squared. So that's your first term. Plus, and then f times L. Well, f is x, L is 5y, so x times 5y is 5xy. So I get plus 5xy. And then plus, and then L squared means L times L, and L is 5y, so 5y times 5y is 25y squared. And so that's 25y squared. And so there's your last term. So you have your binomial times your trinomial. So that was number 3. Number 4, we have x squared minus 100. Now I want you to notice that, again, the GCF is 1, but I have two terms, and the middle sign's negative. And notice this is squared. So let's see if this is the difference of two squares this time. Difference of two squares, because the exponent here is 2. And so remember, the difference of two squares, f squared minus L squared, is f minus L times f plus L. So you have your binomial, your two binomials multiplied together. So the first terms are the same, the last terms are the same, except the signs are different. And so just like we did with the difference in sum of two cubes, let's see if I can complete these parentheses. So x times itself is x squared. 10 times itself, 10 squared, is 100. So there's your f, there's your L. And so according to our formula, it's going to be x minus 10 times x plus 10. And so that is your answer. Number 5, we have 81x squared minus 1. 81x squared minus 1. So again, I have two terms, a subtraction, so think difference. and then you have x squared. So your exponent is 2. So let's see again if this is the difference of two squares. And so let's see if I can complete these parentheses. So always try that first in your mind. You don't have to write it out, but in your mind, that's what you should be thinking of. 9x times itself 2 times is 81x squared. 1 times itself is 1. And so here's your f, and here's your L. So my f is 9x. My L is 1. Okay? And so therefore I get f minus L, f plus L. There's your formula, so you substitute. So our answer will be 9x minus 1 times 9x plus 1. All right, number 6, I have 4n squared minus 16n plus 25. So 4n squared minus 16n plus 25. Okay, so I want you to notice something. You notice that I'm going to go ahead and write it right here. All right, so I want you to notice that, see this first term, that is 2n times itself, right? 2n times itself is 4n squared. And you see this last term, isn't that 5 squared? So let's think, okay, I have a trinomial. I can see that this is this right here, 4n squared, I can write as 2n to the second power, and 25 I can write as 5 to the second power. So is this a perfect square trinomial? So if you see something like that, check and see if that's a perfect square trinomial. All right, now watch. You see this negative 16? So 16 is even, right? So remember our discussion a while ago? So I can write this as negative, subtract 2 times 8n. Okay, 8n. So 2 times 8n. All right? And so I want you to notice that you see this 8n, and then you look at 2n times and 5. There's no relationship between that 8n. All right, so you'll notice that this 5 here, this 8n is not even divisible by 5. So that's not going to be a perfect square trinomial. In fact, if you try factoring this, let's say 2n, just using regular FOIL method, and then 5, and then minus, because the last sign's positive, so you know these signs have to be the same. Notice that when you do the out and the inner, there's no way you can get negative 16n. And even if you tried, so that didn't work. And so even if you tried 4n and n, let's say, and then subtract, and then 5, you'll notice that doesn't work. That doesn't work either. Okay, because that's a negative 20n. That is a negative 5n. You get a negative 25n. So what you notice in number 6 is that number 6 is prime. That's number 6. Number 6 is prime. You cannot factor it. Okay, it's not a perfect square trinomial, even though the outer terms you can write as something squared. The problem is that this negative 16n that you had has no relationship with these terms. Okay? All right, so number 7. Number 7, we have 16x squared minus 24x plus 9. All right, now let's talk about see a while ago when we were talking about this idea here? Let's do that still. Let's do that with number 7. So number 7, I want you to notice this. I'm going to go ahead and put that here. I want you to notice that 16x squared I can write as 4x squared. And then 9 I can write as 3 squared. And then I want you to notice 24x. 24x I can write as a negative 2 times, and then that's what, 12x? Okay? And now I want you to notice this. You see this right here? If I take the 4x and I take the 3x, when multiplied together, does that give me that 12x? Yes, it does. 4x times 3 gives me 12x, right? So that is a perfect square trinomial. So that means when you factor it, those two binomials are the same. So this is a perfect square trinomial. And so when you go back to the previous one, you see right here, you see that's 2n and that's 5. When you multiply that together, that's 10n. That's not what you wanted. You wanted what? 8n. So that's not a perfect square trinomial. In fact, we saw that it's prime. But this is a perfect square trinomial. And so that means then that when you factor it, you're going to get 4x. See this right here? Put that here. Put that here. See this 3 right here? Put that here. Put that here. The last sign's positive. These signs are the same. There's your answer. And you can check it. Always check, though. 4x times 4x is 16x squared. A negative 3 times a negative 3 is a positive 9. The outer is a negative 12x. The inner is the same thing. You get negative 24x when you add them up. And so there's your answer. Or you can say 4x minus 3 squared. All right, so that's number 7. Number 8, I have 25p squared minus 49q squared. So again, notice you have two terms. There's a subtraction symbol in the middle, p squared, q squared. So let's see if this is the difference of two squares. Difference of two squares. And so let's notice it is, because I can rewrite 25p squared as 5p squared. And then I can write 49q squared as 7q squared. And so there's your f and there's your l. And so now you get 5p minus 7q times 5p plus 7q. All right. Number 9, we have x cubed minus 1,000. Now, some students think this is prime. That's not prime, okay? So look, check and see if this is the difference of two cubes. Difference of two cubes. And so let's see if I can rewrite each of those terms as something raised to the third power. Now, I can see that I can write x cubed as x times itself 3 times. 1,000, that's easy. That's a power of 10, right? In fact, it's 10 to the third power. So that's 10 times itself 3 times is 1,000. So there's your f and there's your l. And so remember, our formula is f minus l times f squared plus fl plus l squared. And so the answer then will be f minus l, so x minus 10, times f squared means x times x, so x squared, plus, and then you multiply f and l together, so x times 10 is 10x, and then plus, and then you square l, so 10 times itself is 100. So that's the answer for number 9. And number 10, you have 192x cubed minus 81y cubed. And again, always look for the GCF. And in fact, they gave you a hint here to factor out the GCF. So number 10, you got to think about what the GCF is. So if you look at 192 and 81, let's start with 81. So I know that a factor of 81 is 3, a factor of 81 is 9, and so on. So let's look at 3 for a moment. Let's see if 192 is divisible by 3. So 192 divided by 3 gives me 64. And 64 is a perfect cube, isn't it? 4 times 4 times 4. So 81 divided by 3 gives us, 81 divided by 3 gives us 27, and 27 is a perfect cube, 3 times 3 times 3. So the GCF here is going to be 3. So I'm going to factor out at 3. So I get 3 times 81x cubed minus 27y cubed. And then all you do is take this part here, go off to the side, and work it out. So 81x cubed minus 27y cubed. So let's see if this is the difference of two cubes. So I get, remember this right here is going to be 3 times 3 is 9, 9 times 3 is 27, so that's going to be 3y here. 81, we're going to get, I'm not sure why I said 81, because 3 times, we said it a while ago, was 64, wasn't it? Well, I'm not sure why we said 81 here. I think because I was looking at this. So this is 64, and this should be 64, right? Okay, so for 64, it would be 4x times itself 3 times the 64x cubed. Okay, so there's your f, there's your l. So let's use our formula. Now remember though, this is part of the answer, this factor 3. So we get a binomial, so 4x minus 3y times, all right, so remember our formula. So f minus l times f squared plus fl plus l squared. So I already have my binomial, so let's look at the trinomial. So f squared means f times f, right? And so f here is 4x. So 4x times 4x is 16x squared. So that goes here. plus, and then FL, so F is 4x, L is 3y, so 4x times 3y is 12xy. So that goes here, 12xy. Plus, and then L squared is 3y times 3y, which is 9y squared. So that goes here. And so that's the answer. Okay, so the answer is 3 times this binomial, 4x minus 3y, times this trinomial. Okay? All right, so that is the key to factoring worksheet number 4.